Hi, so welcome to this other lesson of differential equations. So in this lesson, what we're going to do is we'll have a general solution and we will be asked to find a differential equation that gives this kind of general solution. Okay, so in differential equations, general solutions are solutions that you have unknown constants. Okay, so in this particular example here, you realize that there are C1 and C2 in there that we don't know. Okay, so this gives us a general solution. With a particular solution, you don't see any constant in there. Okay, that's the difference between that. And in this particular example, what we are asked to do is to find a differential equation of the family this one, right? So what it means is this is actually a solution of some given differential equation, and we're going to look for that differential equation. First thing to think of is that the number of constants you have in here will determine the order of differential equation. Okay, so here, since we have C1 and C2, we're going to have a second order differential equation, and it means that we'll have a second derivative in there and then the first derivative in there. It can happen that the first derivative will not happen or will not be seen in there, but the order of the differential equation should be a second order differential equation. If you have three constants, you need to get a third order differential equation. If you have one constant, you need to get a first order differential equation. So let's start with this one. We have two constants, C1 and C2, so we need to get like a second order differential equation. So the first thing to do is to differentiate the whole of this equation. So I differentiate it with respect to x. Okay, so dy dx is equal to c1 e to the x plus the derivative of constant c2 is 0, right? So you have c1 e to the x plus 0. Then we have only the first derivative, so we have to find the second derivative because we know from the start that our differential equation should be a second order. Okay, so we need a second derivative. If I find the second derivative of this equation, d squared y dx squared should be equal to c1 e to the x again. Okay, so now what we're going to do is name these as this one to be equation 1, this to be equation 2. You can even start naming from here, that this to be equation 1, and this guy to be 2, and that guy to be 3. Okay, so we're going to do some substitutions to make sure that when we combine all these equations, we're going to do our way, or we're going to be able to eliminate the constants. Okay, so whichever equation you can combine to make sure there is no constants happening in there, you are good to do so. Okay, if you look at the left side of the third equation, you realize that is dy dx, because dy dx is equal to c1 e to the x. 0 is not part, so I can just quickly clean this guy and I still have that. Okay, so this whole side can be replaced with dy ds. Okay, I don't know if you get that point. So dy ds is actually equal to, so you have d squared y dx squared is equal to dy dx. Okay, and this is an equation of only different derivatives. There's no constant, so if you rearrange this, you're going to have d squared y dx squared plus or minus dy dx is equal to 0, and this is a differential equation with a general solution of that form. Okay, so that's the differential equation we're looking for. In other terms, or in other representations, we can say that d squared y could be written as y prime prime minus y prime is equal to 0. If you are familiar with this, you just use that one. Okay, and that is a differential equation with a family of curves, or the family of solution given in this kind of way. Okay, now we go to the second kind of problem, which is this one. Okay, so the second problem says find differential equation of the family that. Okay, so here you realize this equation have only one constant c, so all that we have to do is try to eliminate this constant c. Okay, once we have the reason we need to know how many constants we have is it will tell us the order of differential equation that we need to get. Okay, since this have one constant, the idea is we need to have a first order differential equation. So if I take the derivative of both sides, so I'm going to call this side equation 1. So the first derivative will be equation 2. dy dx is equal to c, or maybe 3c x squared. Okay, we need to be able to do derivative straight away. That's why I just do it straight away. This is equation 2. Now from equation 1, right, what can you say? We know that c is equal to y divided by x cubed. Okay, that is, if you divide both of these equations each side by x cubed, you have c to be equal to y over x cubed. Now what does this mean? This means that we substitute this c into equation 2 and it will have dy dx to be equal to 3 times c, which is y over x cubed, times x squared. Alright, and then rearranging and simplifying, x squared can cancel 2 of these and then you'll be left with x. Okay, so you're going to have dy dx to be equal to 3y over x. Okay, and this is our differential equation, or you can say dy dx minus 3y over x is equal to 0. That's the differential equation we are looking for that have this family. Okay, or in the other representation you have y prime minus 3 over x y is equal to 0. Okay, and that is the differential equation we are after. I'm going to do other set of examples working these things. These are pretty much straightforward. The other examples I'm going to work in the subsequent videos are going to be a little bit tricky, so you just have to stay tuned. Okay, and follow for more videos on differential equations. I just wish we'd be able to finish differential equations earlier and then go to partial differential equations. Okay, see you in our next lesson.